Okay, this is map 13. We're going to interpret the map first before drawing the cross section. So what features can we spot on the map? Well, one of the most obvious ones is this boundary, which runs in a north-south direction. It's slightly wibbly and it cuts across older structures such as the fault down here and the Pluton up in this corner. It is an unconformity. The unconformity is dipping at 10 degrees towards the east. These three layers have got the same amount of dip, so they're concordant with each other, but they're discordant or they cut across the older layers below. So let's mark on the unconformity. Other things to spot on the map is the Pluton up in the top corner. It's a large igneous body. It is discordant and it's got a circular outcrop pattern. It's also got a metamorphic aureole on the outside of it. I would also suggest that this other igneous body here, because it's got a metamorphic aureole above and below those two layers, that this is a sill. So this is a layer underneath the sill and this is a country rock above the sill. So this is older, this is younger. This is also older because it's closer to the unconformity. What else can we see? Well, we can also see that we've got repetition of rock units. This layer in the middle is not repeated, but these two layers are on either side, and so is this one. There's also change in dip direction. Before the centre, these rocks are tilted towards 45 degrees towards the west, and over on this way it's 45 degrees towards the east. So this will suggest that in the middle down here we've got an APT for a synform. And we can draw that on. I would also suggest that the APT continues below this fault in the same position. We said it was a synform, so let's put bow tie on it. So we've marked on the APT of the fold. The fault itself, we can suggest that it's a vertical fault because it's a straight line, but it's also got vertical displacement. The reason I know this is the synform is wider on the southern side of the fault, suggesting this is the downthrown side. Using Swan, synclines are always wider on the downthrown side. Antiforms are always narrower. So this is a synform, so it's wider, so this is a downthrown side. I'm going to mark the ticks on to show that this side, the southern side, has moved down, this side has moved up. As with any cross section, we need to work out the order in which we're going to construct it. Looking at the map, we can make some very, very quick decisions. The Pluton is not going to be on the map, so we can ignore it. So is the fault. So we're concentrating on is the fold, the unconformity, and this igneous body, which is a sill here. So I suggest that you do this section first because it's the youngest, so anything above the unconformity. And then you're going to do the folded layers afterwards. Okay, so we're going to do the unconformity and the layers above the unconformity first. So we're going to mark on the boundary, and it's this point here that the unconformity is. It's dipping at 10 degrees towards Y. We know that the unconformity cuts across the folded layers. I'm going to extend it further out. I don't know how far it will have gone, but we'll just project it that far. Let's mark the layers which are situated directly above. So this is the base of the intrusion. Base of the sill. And this is the bullet. I'm just going to put little metamorphic orioles symbols on there as well. There we go. So what we've got to do now is put in the fold. So I know these two boundaries are going 45 degrees towards the centre, and these two boundaries are that one and that one are going to join together, and those two are as well. Key with this is always to make sure that you don't extend the line too far down, because you're going to have to join points up. Always do it with the light pencil and finish off the fold afterwards. So those two boundaries 45 degrees, and they're going to meet towards the centre. So we've got a vertical and upright fold axis for our sin form. Put our axis in. There's our symbol. Let's make sure that we've put the rock types in. We're going to assume that everything underneath here is the same rock type. We can't prove it because Unconformity is hiding it, but we'll assume that everything is the same. There's our vertical or upright fold axis. Both limbs have got the same angle on either side. There's our Unconformity with our igneous body. You're finished.